Hello once again, everybody. My name is Justin Miller, and welcome to Wowza Webinars. This is the How Low Can You Go with Low Latency series, and this is part 2, WebRTC, Is It Right for Me? So today, joining us, we have our Product Marketing Manager, and Balastari, and we also have Andrew Kennedy, our Director of Engineering, with us. Hey, Andrew, how's it going?
Going well, thank you. Sorry, it took me a while to find the mute button.
No problem. Andrew's all the way over in the UK, so just want to make sure that he's coming through loud and clear for you guys. If you do have any audio issues, please feel free to let us know. And we also have Jason Tuchler. He is our technical support engineer. And, you know, Jason, I'm not actually sure. I assume you're in California, but where are you?
I'm in Northern California.
You are in California. All right. So, all right, yay me, I knew that. So once again, for people who have just come into this webinar, I just want to remind you, there is a bit of introduction here. We go through a presentation at the start, and during that time, if you do have questions, you are welcome to type them into the QA window. From the QA window, we will either answer questions directly during the Q&A session at the end, or Jason will answer some questions as they come in. As well, I have a few polling questions I'd like to ask you. If you guys don't mind, I'm going to launch this poll right now. And I'm launching the poll. And the first one there is asking, are you currently streaming live video? So please let us know if you are. We always want to know how you're coming to this webinar, whether you're already in the business or not in the business. The second question is, what type of latency do you see in your stream? And we have options between only 3 seconds or more, 6 seconds or more, 10 seconds or more, 15 seconds or more. Always good to know how bad of latency you're working with, or rather how good latency you have, depending on what it is. We also are curious if you are currently using us. And generally speaking, if you're using us, or using our Wowza Streaming Engine or Wowza Streaming Cloud. I personally am an Engine fan. That's just me. I like to install my own things. I definitely like to use it on, let's say, an AWS instance, you know, do an EC2. But hey, last question, because I don't want to keep talking about myself. What industry are you in? We definitely want to know. Are you, for example, a software developer? Which brings in the question then, are you using our Wowza SDK, which is free? Maybe I should add that in question 3. Do that next time. But as well, are you working in live events, government, or are you a broadcaster? Okay, I'm going to leave this poll on for just a few more seconds here. But as I did want to mention to those people who are typing into the QA window, guys, I definitely appreciate you answering some of those questions about what you're looking for in terms of WebRTC, what your use case is. And I'm going to end the poll right now, and I think we are going to start the presentation. So, ending the poll, and you're welcome to see it yourself. And all right, take it away, Ann.
All right, hi everyone. Thank you for joining us today for today's webinar on WebRTC. We're going to start by talking about what WebRTC is and how it fits on the low latency spectrum. After that, we're going to move to a more technical discussion about how WebRTC works in WebRTC under the hood. From there, we'll discuss how to determine if WebRTC is right for your use case, and then how to move beyond peer-to-peer communications by powering WebRTC with the Wowza Streaming Engine. So this portion of the webinar should only be about 20 minutes, and afterwards we'll move into the expert Q&A so you can get all your questions answered. All right, so moving on, streaming latency and interactivity continuum. So we touched upon this slide in the first webinar in the series about ultra low latency, but let's briefly go over it again for the new attendees. Common latencies tend to be 15 to 45 seconds. This allows the stream to supply enough frame buffering so the end user should experience no disruptions in their viewing, even with network blips. This also allows for multiple bitrate streams to be supplied so that the end viewer can receive the best stream based on her network speed or accommodate for variations in network throughput. Let's specifically look at WebRTC. WebRTC is typically well below the 1 second time frame and is considered what we call real time. It's important to keep in mind that not all live streaming solutions need to be concerned with ultra low latency in real time, but for those people building out solutions that need real-time interactivity, like two-way web conferencing and real-time device control, the lower you can go in terms of latency, the better. Some other common protocols in this area include ULL, RTMP, Wowza WebSockets, RTSP, and SRT. But again, it's not the scope of this webinar to go into details of each protocol, but it's helpful for new users to understand how they fit into the spectrum. So, what is WebRTC? WebRTC is a free open framework project for the web. As the name implies, it enables real-time communications through browsers. This combination of standards, protocols, and JavaScript APIs create a near simultaneous exchange of communication, utilizing a peer-to-peer connection between browsers without requiring plugins. So what does this really mean? At a high level, if you're a programmer building a software application, you can build WebRTC support into your application to allow conferencing between individuals and small groups. Users communicate through their web browsers in real time, just like a face-to-face conversation. So going down one more layer, let's discuss how WebRTC works. WebRTC employs 3 categories of HTML5 APIs that are built into Chrome, Firefox, and Safari browsers. The 3 main categories of APIs are media capture and streams. So this is going to allow you to get access to the device's microphone and video camera via JavaScript. To get over privacy issues, when these APIs are called, the user is asked for permission to give access. Next up is Rtcpeerconnection. This is the heart of WebRTC, where most of the implementation lies. These APIs allow you to send the captured video or audio across the internet in real time. They create a connection between the 2 peers, maintain, monitor, and close the connection when it's no longer needed. Next up is RTC Data Channel. It's a generic interface that can carry any type of data, media or otherwise, between 2 WebRTC devices. Some have adopted the data channel for online file sharing and assisted P2P video streaming, but it's really important to note that at this time, Wowza does not currently support this API. All right, so the industry talks a lot about WebRTC's ability to operate entirely in browser, and that's true from the end user's point of view. But say we have 2 people trying to communicate via live video, and we'll use myself and Justin as examples. If I want to have a conversation with Justin, my browser can talk to Justin's browser without a server, no problem. But here's the caveat. Because there's no service discovery, you still need a signaling server so browsers can find each other. Think about signaling as the initial handshake, and the process looks like this. My browser says hi to the server and registers. Justin's browser also says hi to the server and registers. Then the server holds on to a list of identifiers, which would be our usernames. My browser tells the server to call Justin's browser. The server tells Justin's browser there's a call. Justin answers the call. Now Justin and I are talking back and forth. It's really pretty simple when you break it down. Peer-to-peer video is simple in that way, but it does get much more complicated if you want to scale your video to a large audience, but we'll talk about that a little later on. So moving on, is WebRTC right for your use case? We talked a little bit how it works, but let's talk about if it's actually right for you. WebRTC is not a brand new technology. It's been around since 2011, but not without some controversy and ridicule. Now that Flash is fading and HLS and MPEG-Dash are considered to be high latency alternatives, many people are looking at WebRTC as the live low latency streaming solution. But due to some of its disadvantages, some critics believe WebRTC is not the be-all and end-all. In order for you to make that judgment call, though, we need to take a closer look at what it does well and what you may want to think twice about using it for. So, Let's talk about the good stuff first. There are certain things that WebRTC works great for. The first one being peer-to-peer communications. If you're creating a software solution that only requires communication between two people or a very small group, then WebRTC is definitely the way to go. I read a really great analogy that used an example of an airport to explain the definition of peer-to-peer. Think of it like this. A server acts like the hub for a major airline. Flights stop at the hub so that passengers can connect to their destination. Passengers may need to go through baggage claim or immigration, layovers, and delays, equivalent to the processing that may take place on the server in the middle. However, isn't it much, much faster to fly direct? That direct communication between two browsers is what we're calling peer-to-peer communications. The element of delivering the passenger faster to their destination leads to the next benefit, which is real-time interactivity. As long as you're using WebRTC for publish and playback, the technology supports real-time communications, less than 0.5 seconds, in good network conditions. Keep in mind, this real-time interactivity only works for small use cases, meaning one-to-one or a small group environment. The last major benefit of WebRTC is the fact that you can build or broadcast through a web app quickly and easily without heavy infrastructure. Since WebRTC makes use of HTML5 APIs, it allows you to utilize many of the features built in the HTML5 programming language through a lightweight embedded framework. This makes it easy for developers to build web-based apps using WebRTC, for users to take advantage of the functional offerings without having to download clients or some plugins. Some of the features enabled by WebRTC include the ability to screen share and to perform browser-based encoding. So users can live stream from their browser window to other viewers and participants on the web. So what it's not good for. WebRTC has some great benefits, especially if you're creating an app or solution for a very small audience. However, WebRTC is not a perfect technology and does have some pitfalls when using the technology without a media server. Things that it's not a good fit for include viral viewership spikes, broadcast quality streaming, and live repeater configuration. So there are three components of live streaming that make up what we call the live stream trifecta. Those three components are high quality, the ability to scale, and low latency. You may be able to obtain one or two of these in your stream, but it's really hard to get all three, although it is possible. When we're talking about WebRTC, we know that its strong suit is definitely low latency. But what about the other two? WebRTC by itself has a much harder time achieving large scale and high quality. So viral viewership spikes. We talked a lot about how WebRTC is great for small audiences, but what happens if you have a sudden spike in viewership for viral content, or you need to video conference to a large audience? WebRTC alone is not enough. It has a very limited ability to scale without a network of servers that can handle the load. Like we learned earlier though, every time you connect one browser to another browser, you're creating a peer-to-peer connection. If you have 10 viewers, you're creating 10 separate peer-to-peer connections. That may be okay for 1 to 10 viewers, but what happens when you get up to 500, thousands, or even millions? There are limits to how many connections a browser is allowed. Chrome limits the connections to 500, but many experts agree that that limit is actually closer to 50. If you expect 500 or more viewers and you don't use a server, you can expect to have some issues with your stream. Another sought-after requirement for live streaming is the ability to broadcast a high-quality stream. It's important to note that as of today, you can't reliably stream broadcast quality video through WebRTC infrastructure. WebRTC prioritizes low latency transport, so speed, over stream quality. So it's not great to watch or listen to content. To ensure high-quality video streams, you need three things: a certain bit rate, speed, and level of network connectivity. One thing that you can't control is the network or connections your viewers are using to access your content. Additionally, WebRTC is limited to supporting VP9 and H.264 video. Last up is the live repeater configuration. So very low latency delivery requires careful network and server deployment in order to maintain consistent performance when traversing multiple network nodes. It's possible to configure Wowza streaming engine for very low latency, but it's not supported yet, and it's currently being investigated at this time. So to use or not to use WebRTC, these are the best use cases for the technology and the use cases you'll want to think twice about. It's great for audio video calling, so enabling your app or website to support calling between two visitors. It's also great for online conferencing for a small group. This is the preferred method of bringing together a panel of people in collaboration with their web browsers. It also works great for live presentations. This could be product demos or interactive live trainings. What you want to think twice for is using it for traditional broadcast or audio streaming. Because WebRTC prioritizes speed above anything else, often quality of the stream in terms of definition and audio can be compromised. You also might want to think twice about using it for chat services. And this is different than video chat. So when I'm saying chat services in this application, it would mean help desk chats or sales chats that serve as in-app messaging. We don't recommend chat services as a use case because they tend to be asynchronous, meaning that your chat service would still be able to send messages to your recipient, even if they aren't connected to your service at the time your message is sent. Another thing we don't recommend it for is multiplayer gaming. There are other alternatives out there that work better for this use case. So if you're creating a multiplayer gaming app, you may want to use something other than a peer-to-peer mesh network. Something like Wowza Streaming Cloud's ultra-low latency service would actually be a better fit for this use case. All right, so let's get into WebRTC powered by Wowza Streaming Engine. WebRTC used with Wowza Streaming Engine can help alleviate the issues we talked about earlier, like scalability and optimizing bandwidth. It can also generate, record, and deliver low latency browser encoded streams without the need of additional encoders or plugins. I want to take a look at this quote right here. If you are broadcasting, then a media server is mandatory, and no, Google does not offer such a free service or even open source code that is geared towards that use case. So what he is saying is true. WebRTC is a nightmare at scaling. So if you plan to broadcast to a large audience of passive viewers and listeners, you're going to want to put something like Wowza Streaming Engine in place so you can go beyond peer-to-peer connections. When you power WebRTC with Wowza Streaming Engine, you can actually ingest WebRTC streams and use the transcoder feature in Wowza Streaming Engine to transcode the WebRTC stream into any standard output format. Then you can deliver the stream over Apple HLS, Adobe HDS, or MPEG-, which enables you to scale your WebRTC solution without the significant bandwidth that would otherwise be required to deliver your streams to viewers with high quality. It's important to note that latency will increase, although it may be minimal, the stream will no longer be in real time. One way to ensure low latency and scalability is by using the Stream Targets feature to send the stream to Wowza Streaming Cloud's ultra-low latency targets. Next up is bandwidth optimized video conferencing. So this is the next benefit of using Engine with WebRTC. With general out-of-the-box WebRTC, if you want to have 3 or 4 people talking to each other, it's required that every person has to connect to every other person. If I was to have a video conference with 3 people, I would have to send a stream from myself to the 2 other people directly, and they would have to send their stream to the other 2 people as well. This creates a complicated mesh network of streaming that increases the bandwidth load, and as I add more people to the video conference, the bandwidth continues to go up. If I add Wowza Streaming Engine in the mix, each participant only needs to send a single stream from a web browser directly to Wowza Streaming Engine. Then every viewer can connect and see that single live stream in their web view. This significantly reduces bandwidth consumption. It makes it much simpler to set up multi-person video conferences using WebRTC. And by doing it this way, you can enable low latency sessions between multiple users, while at the same time optimizing bandwidth by minimizing the number of connections each client must establish and maintain. Last up is browser encoded streams. So this is the last major benefit of using WebRTC with Wowza Streaming Engine. And it's the ability to generate, record, and deliver low latency browser encoded WebRTC streams without the need of additional encoders or plugins. Now you're able to fire up a web page or capture video off a webcam, send it to Wowza streaming engine, take the stream and distribute it out in WebRTC for playback, or transcode it in H.264 and AAC, so it's playable back in HLS or RTMP, so that others can view and see that video live as it's happening. It's actually very powerful, and you're able to use your browser on a desktop or mobile device to encode video, send it to engine, and send it out in a low latency way to your viewers. With that, we're actually going to wrap up this segment of the webinar. I hope it helped you understand how WebRTC works and if it's the right technology for your project. But before we head into the Q&A portion, I want to make a couple announcements. We are very, very excited to announce that WebRTC is out of preview and is now a supported technology of Wowza. We're also offering a 180-day developer trial to anyone that wants to develop with WebRTC. You can sign up for that trial by going to wowza.com/mediaserver/developers/license. It's kind of a long URL. We're also running a promo for Wowza Streaming Engine until we wrap up the webinar series on January 10th. All webinar attendees will receive the following discounts. We have 25% off perpetual, annual, and monthly plans, 40% off perpetual pro pack, 15% off gold annual premium support. That's for the first year only. If you're interested in any of these promotions, please email sales@wowza.com to receive your discount code. All right, next up is Q&A with the experts.
All right, Anne, thank you for that. Definitely appreciate it, and I hope all of you do as well. Just before we start getting into QA, which, by the way, I see Andrew and Jason have answered quite a number of those QA questions. Definitely thank you, Jason and Andrew, for taking a look at those. There are a few already in queue, as many of you have seen. I'm going to reiterate the question just to make sure everyone knows which one we're answering. But I also did want to relaunch our poll. You know what, I'm not going to because it'll clear the existing poll. So never mind. Let's go instead straight to the question. So Raj had a great question. I'm just going to go from the top down, guys, if that's okay. And the first question, which feel free, Andrew, Jason, whoever wants to answer it. The first question is, will the slides be available after the meeting is over? I see. Well, that's a good question for me, actually. Certainly, we'll make the slides available for you afterwards. We also have a recording of this webinar, so we'll make both of those available. It might be a day or two before you receive that email notification, but definitely it will be available. Okay, so next question. All right, I'm going to dismiss that one. Okay, Martin asks, is there a sample to use as a kind of blueprint to record with Wowza a webcam recording? Was one in Flash, which we are currently using and would like to replace.
So currently there is no example on recording as was there in Flash. It's a really good idea though, and it's something we should take away and look at.
All right, Martin, I hope that helped you out. Definitely, we'll need to look into that. And I do appreciate you asking it because definitely our engineers as well as our sales team sees these kinds of questions they're asking right now and takes those things into consideration. Okay, next question is, does Wowza Streaming Server have to be deployed at every streaming node to provide scaling with WebRTC?
I could answer that question, and we don't support edge servers with WebRTC, and it's recommended to use Wowza CDN or Wowza Ultra Low Latency to handle your scaling of WebRTC streams in the higher volumes of, think about 1,000 and above.
All right, Jason, thanks for that. I think someone else who was in our chat was also talking about no edge. So sounds like we definitely have an interest in that, but it also sounds like our CDN is definitely the way to go. Val is asking, do you know, is HLS with all the optimizations match Flash? How far off?
So from a latency point of view, it's very, very similar. Flash was pretty much within the 1 second to 4 second latency. WebRTC is very much in a similar vein of that, depending on the network and a whole bunch of other things. But yes, it's pretty much the same, if not slightly quicker.
And Val, I think this is still your question here. You also say you're currently looking to support PTZ cameras and you need your latency to be low. So I hope that helps to answer your question. Oh, and I'm obviously wrong because it was Omar asking that question. I have too many screens open here. I do apologize. Okay, Val is also asking. She wanted some of the WebRTC overview. Val, again, this is being recorded, so we'll definitely give you a link to this. Chris is asking, is video/audio recording supported from Apple devices using H.264?
So we do support recording on Streaming Engine, and you can record H.264. The recommended workflow for recording would be to transcode the audio that comes from WebRTC, which is normally Opus, into AAC. However, we can also record Opus. Right now, playing back the file is more of a challenge. So recommended would be to convert it to AAC and record it that way.
All right, thank you for the answer, Andrew. And Michael's asking, should I use VP8, VP9, or H.264? Which is best for low latency streaming?
I would recommend for the most stability across browsers using H.264. But VP8 is another option too. But yeah, well, I'm trying to think on what do you think, Andrew, in our testing?
I think the best one you're right would be H.264, simply because you get the most support on devices, and it's the most testing we've seen and seen other people use. So I would stick to that.
Yeah, and I don't see a difference in the latency. Actually, VP9 might add a bit more CPU resources, and it might create more lag.
All right, thanks. I'm gonna move forward. What is the lowest E2E latency that can be achieved with WebRTC ingest and using ultra low latency targets within Wowza streaming engine when the goal is to deliver a low latency stream at scale?
So I'll give you an example of some testing we've done recently. Obviously, you can probably go lower than this, but we had a source in the UK and was pushing over to a server in Ohio, and then we had people watching on the West Coast who were connecting to the server, and latency end-to-end was sub 500 milliseconds from me doing something to somebody else seeing it. Now, that is pretty low. Obviously, we think that is kind of unachievable in a full production scale. You're probably looking at somewhere like 600 to 700 milliseconds, but you may also be able to go lower, but based on a variety of criteria.
Awesome, thank you for that. Chris wants to know basically how does he get started? I mean, does WebRTC functionality require an additional license?
There's no additional license. It just comes with Wowza Streaming Engine, a perpetual or monthly license. And you can test it out with a developer license or trial license. Ideally, a developer license because SSL is required. Okay,
well, Chris has a engine license. So what does he need to do next to get started?
Engine license, he'll need to, we have a WebRTC setup guide with Wowza Streaming Engine. I'll post in that link for him.
Okay, great. If you could post it in the chat, that would be awesome. Chris is also, another Chris, a different Chris, is also wanting that this recording. So again, we'll definitely make it available after the webinar is over. Anton wants to know, does the current official release of WebRTC support built-in turn server? I am not familiar with the turn server, so hopefully, Andrew, you can answer that question.
So currently we support stun. It will support some functionality in turn, but not all of it. So One of the things we've been testing is obviously with EC2 and making sure it works in that environment, which is a public to private environment, which is where Turn and Stun are used. You would need to give us a bit more of your use case to make sure that we can support what you need. So please follow up, either open a ticket or follow up with the questions later, and we can get you more details there.
Thank you, Andrew. And Anton, again, definitely our salespeople do read these questions. So, please feel free to explain that question in longer terms as a Q&A question. And if we don't get to it in more detail, definitely our sales team will follow up. And just pass something. Hold on a second here. I dismissed one, guys, that I think was important. Oh, yes. Does WebRTC offer a lower latency than HLS?
It does. HLS is a HTTP protocol, which is chunk-based. And default is 3 10-second chunks that could be knocked down with some settings changes to maybe about 6 to 8 second range. And WebRTC, usually in good network environments, is going to be sub 1 second.
Okay, great. And we have another question asking about encoder hardware to go into Chrome with WebRTC. Does it just use your webcam, or is there other encoder hardware available out there? Does anybody know?
It uses get user media, and from a camera that's attached to a desktop or to a laptop.
Okay, so basically it's like something that comes in via USB 3 or USB-C, something like that.
As long as the station can detect the camera,
Gotcha.
the browser should be able to do that.
So someone's asking, like, for example, 360 cams. Would a 360 cam work?
Andrew, I would think no, because you would have to have the stitching available.
So the camera would work, but you wouldn't get any 360-degree view. So you'd get probably quite a strange output because you'd get a flat view. So although the encoding may work from a H.264 output, it wouldn't look 360, which I think is more the angle of the question, I hope.
I think so. I think they're basically trying to understand what capabilities they have with WebRTC. And another question being is, WebRTC supports 4K, and does Wowza Engine support 4K via WebRTC?
Well, we do support 4K because ultimately it is just a bitrate resolution. It's obviously the bandwidth usually that's the issue there. We do support 4K, but it's then getting a WebRTC 4K stream, which I have not seen anybody be able to produce. So certainly there should be no issue. However, it's not something we've tested.
Thank you. And I see someone's also asking about audio. They say AAC via WebRTC. Will that be supported soon?
Probably not. Unfortunately, due to the way that WebRTC has been kind of deployed, they're trying to keep to the open standards codecs, and so therefore AAC is not one of them. So really, you've got a couple of choices with WebRTC. You've got Opus, which is primarily the default for most browsers, but you can also use PCM, and you can also use Vorbis.
Great to know. Chris is asking, does Wowza Go Coder, and I'm assuming this is through the Android API, support WebRTC? And as well, does it support it with SSL encryption?
We do not have, within our Go Coder SDK apps, support for WebRTC. We do plan to have samples available in the future.
Good to know. Hey, thanks for answering that one. Another question is, Sebastian wants to know, hey, did you finalize Wowza Player with the option to remove the Wowza logo? Which I've never seen the Wowza logo in Wowza Player, so interesting question.
We used to have the logo in our first few versions, but if you use the latest version of Wowza Player and header, you will not see the logo.
Sebastian, I hope that answers your question. You also say something about solve browser detection compatibilities and provide to the viewer the best possible playback. So I'm not sure if there's a question in there, but if you do have further questions about Wowza Player, please feel free to type them in. Philip's asking, do all the users have to support the same codec used by the publisher?
Nominally, yes, because you're trying to play back the stream from the publisher. What you can do is you can use the Wowza transcoder to convert the audio primarily, in most cases, to something that the player can actually play back. So HLS, for example, so converting Opus into AAC, then packaging HLS. So there are some options there.
Awesome, great. Lewis wants to know, is WebRTC good for the security industry? For example, to broadcast a RTSP stream. So I guess he's thinking about IP cameras.
Unfortunately, WebRTC does not support RTSP in. It would have to be WebRTC to WebRTC out, or WebRTC to our other Transmux available protocols, such as HLS. And for security-wise, we do have sample code where you can add query strings and we do handling of that.
Awesome, good to know.
So it could be like a username password as a query string, then do handling.
Okay. Hey, we got an STR question. Is that SRT, you think?
Maybe.
They say, does STR, which with Anton, I'm going to assume you mean SRT, available in Wowza Cloud? No, then that probably is not. I don't think we have STR. Do we have STR in Wowza Cloud, guys?
I'm assuming it's going to be SRT, but I think it may be something that's coming along in the near future, but not yet. If you're looking at, let's talk about SRT and WebRTC for a moment. Realistically, the latency is very similar. They do things in slightly different ways, slightly different support, and slightly kind of, you can't play back SRT within the browser and so on. But from a latency perspective, they're very similar.
All right. Well, again, though, we don't do SRT at this point right in cloud, right?
No, we don't. It's something they're looking at, but it won't be available for a while.
All right. Good to know. When peer-to-peer groups share video data, how does it currently impact their mobile data plans?
It should only affect the data that they're sending out on the broadcast or coming in. Wowza will be the one that handles the bandwidth.
All right. And Val wants to verify which browsers are supported for playback in our scenario.
You want to go ahead, Andrew?
That's unfortunately a bit of a contentious one based on a variety of testing and changes. One of the challenges with WebRTC is that as browsers evolve and update and so on, support for WebRTC kind of changes and things break and so on. But right now, with Chrome, definitely, Firefox for publishing and playback. We're looking at Safari for publishing and trying to look at Safari for playback. However, a lot of people ask for Edge. Right now, well, we can't see that working in the foreseeable future. So realistically looking at Firefox, Chrome, and Safari.
Awesome. Firefox, Chrome, and Safari. Extending that kind of question, I think some people want to know a little bit about the possibilities of adaptive bitrate with that in the future. Is adaptive bitrate even possible with WebRTC?
So the specification does lend itself to be able to do kind of a variable bitrate streams and so on. We're not going to be supporting that part of the specification.
Good to know. Chris wants to know if there are any Wowza approved third-party developers that are experts in WebRTC solutions.
We might have some. I could look into that. If Chris, if you can make a support ticket, I'll find you one if there is one available. Let me send you a link on how to create a support ticket through the chat window.
All right. And Pete wants to know, how does WebRTC compare with CMAP when it comes to latency and scalability?
So right now, WebRTC in theory should be lower, But of course, there is some advancements in CMAF over the last 6 months where you have continuous download or continuous presentation of data to clients, and so you can be right at the kind of live point with CMAF if it's deployed in that way, and certain versions of CMAF. For us right now, we'd say the latency was pretty similar, but that may change.
And Pete, just so you know, we actually are going to talk about CMAF in more detail coming in February. So if you want to check out that webinar, hopefully, if we're going to make it available, we'll announce it soon. What is the possible stream targets in the future with WebRTC? I think some people want to know if we can stream target other, I don't know if this is social media or what the options are looking for.
I think he's referring to using a edge server to pass on to other WebRTC servers, or to use a second server to transcode. And in the future, this is still unknown on if we'll be supporting.
All right, fair enough. I'm going to do an off-topic question from the top there where Edgar is asked, when will waiting for calculation log messages be fixed? So I don't even know if this is a question for you guys.
So that is a very old, I'll be very clear, it's a very old bug. It's been identified, and it is in what we call story. I don't know the timescales of being fixed. I understand why you're asking it, because it basically fills up your logs with messages. So it is on the roadmap. I don't know when.
Fair enough. Sorry guys for switching the topic there. We will get back to WebRTC right now. Sergey, the next question is, what is the suggested configuration of PC/server that does a WebRTC stream? He said, I understand it depends on the number of users, bitrate, bandwidth, etc. But they want to know the suggested configuration.
So right now, we would recommend our production level specification that we have on the website, which I believe is 16 gig RAM and 8-core server, but please check the website. We have suggested production hardware.
Awesome. So we do have tech specs on the website if you want to take a look at that. Anton has some more questions. He says many networks block WebRTC UDP traffic. Turns used for firewall traversal. Right now, we need to deploy a standalone turn server. Wondering if Wowza has plans to provide their own turn server as part of Engine.
So what would be really good is to get exactly your use case. I think this question was asked earlier in a different way. Let's get the use case, please open a ticket, and let's get the details of what you're after. We do provide some functionality in that area already, and certainly we'll good to see what you want to do.
Yes, and Jason did provide the URL to open up that ticket, Anton. You want to take a look at that. Franklin, and by the way, guys, we are getting close to the end of this webinar, so from this point forward, we won't be answering any other questions. We're going to focus on the few questions that are remaining right now. But Franklin is asking the example of a browser connecting to a Wowza application with authentication. So I think he just wants an example of how a browser connecting to a Wowza application might work with authentication.
Franklin, this was brought up a little bit earlier, but we do have sample code where you could use query strings and use that as authentication. I'll send in a link to that article within the chat window for you.
And I think you asked that, Franklin, right? You wanted examples of video chatting connections to an authenticated application. So Jason will send that over. Isabel wants to know, another question for me. Yes, this webinar is recorded and we will definitely send it to you for sure. It may be a day or two before you get that email, just so you know, Isabel. And next question is how to use computer/phones SoC to HW hardware, I assume, encoding via WebRTC. So basically, I guess you're trying to use a hardware encoder, Dennis, to point hardware to the encoder, not software encoding. Yeah. So I think we talked about that hardware before was something that had to be connected to the computer. But Andrew, do you want to go into any detail on that?
So I suspect that you're also asking, basically, can you use the GPU rather than necessarily software encoding? Right now, my experience of testing with both Chrome, Firefox, and Safari, there doesn't appear to be a lot of GPU use, although Chrome, I can see, does do some. So I'm not entirely sure there, but I suspect that's either it can be done completely or not and would need more investigation.
Awesome. Philip is talking about converting audio codecs. They want to verify that in the process of converting audio codecs, you add latency.
Yes, you will. There is a buffer within the transcoding, so therefore you would add some latency. It is possible to reduce the latency with the Wowza transcoder. By default, I think it's in a range of 150 milliseconds. You can bring that down to about 75 milliseconds. So, and because it's just audio, it shouldn't be too much.
Awesome. Chris is asking, is there a way to authenticate users' accessing a stream or restrict, or with the URL can determine who can consume the stream? I think he's trying to find more security tools for WebRTC.
Yeah, that's it. That's an example where for the publish and playback, where you can add authentication, which is posted in the chat.
Awesome. Okay, we got 2 more questions, and we might add this one question that came in after. Sebastian says, I was expecting you to describe a little bit more about Wowza Player's integration with WebRTC, low latency, and not only with your cloud offer. I don't think we discussed WebRTC with cloud offer, but there's few documentation on your player, especially for low latency. So I guess Sebastian's really wanting to utilize our player with WebRTC.
Right now, our player does not support WebRTC, and I don't know whether it will.
All right. Thank you, Andrew. Simple enough answer there. Leonardo says, for security cameras, I think we kind of went through this before. WebRTC doesn't accept RTSP, but the question is, for security cameras, is there a way to convert RTSP streaming using Wowza and display on a browser using WebRTC? So they want to go from RTSP to WebRTC.
I mean, this was discussed earlier. It's not supported. They would need to go WebRTC to WebRTC. So they will have to use the browser to pull in the camera stream.
Fair enough. Yeah, I think at the end of the day, the solution, as we mentioned, needed to go. WebRTC is really through the browser, and it's not connecting to IP cameras per se. Last question I got for you. Does Wowza WebRTC support RTP endpoints for connecting WebRTC to SIP clients?
No, it does not.
All right.
There we go.
Well, that's it, guys. Simple answers. Glad you could come here and ask them. If you do have further questions, obviously, we do have the links that Jason made available there for you to open a support ticket with us. But I definitely want to thank you all for coming to this webinar. We really appreciate it. And just make sure, Anne, if there's anything else you wanted to chat about?
Yeah, just that we have the last webinar in the low latency series on January 10th. So we'll be discussing SRT with the SRT Alliance co-founder Haivision. So we're going to be diving into the mechanics of SRT and best use cases and what to expect from the technology in 2019. So make sure to sign up. And again, that date is January 10th, and that will be the last in our series.
All right. Thank you, Anne. Thank you, Andrew. And thank you, Jason, for helping everybody online. I see they love talking to you guys there. So I appreciate, again, everyone taking the time to join us, and I hope you all have a great day.
Thank you.